Assalamu alaikum wa rahmatullahi wa barakatuhu, and very good morning to all of my dear student. Today we will start the next topic, scattering of light and its application. Okay, scattering of light. That is chapter 6C. This is the chapter 6C. Now, scattering. What do you mean by scattering? Okay. Now, look at this. Here, this is the dust particle. In our environment, in our atmosphere, there is a dust particle. Okay. I'm making the dust particle very big. But the size of the dust particle, if the size of the dust particle is smaller than the wavelength of the light, okay, then what happened? The light falls. This is the light rays. Okay, when pass through the dust particle, and if the dust particle, the size of the dust particle is smaller than the wavelength of the light, then what happened? If it is smaller, then all the light will absorbed. First absorbed. Okay, and after absorbing, mind it, when it will absorb, when the size of the dust particle is smaller than the wavelength of the light, this light. Okay, now if the size is smaller than the dust particle size is smaller than the wavelength of the light, then the light first absorb in the dust particle, and after absorb it will re-emit. It will re-emits in all directions. Okay, first absorption and then re-emission. That is the phenomenon. This phenomenon is called the scattering of light. Absorption and then re-emission in all direction. Okay, that phenomenon of light is called scattering of light. But what is the condition? The dust particle must be the size of the dust particle must be smaller than the wavelength of the light. This is the condition. Clear? So what is scattering? Scattering is the process of absorption and then re-emission of light energy by the dust particle and air molecules present in the atmosphere. Question will ask that why this will happen, absorption and re-emission. What is the main condition? What is the condition for absorption and re-emission? This is the condition. The size of the dust particle must be smaller than wavelength of the light. Okay. Now, here, violet color light in VIVGEOR, that is in VIVGEOR, violet color light, violet scatter most, red scatter least. Okay, so those are scatter, the color which is scatter most, the scatter least, they can travel long distance. Long distance. Okay, and they do not travel long distance. Okay, red light scattered least. Scattered least means here if this is the source of red light and this is the source of violet light, so this one will travel like this, little bit scattered. Okay, but violet they scattered like this. So very few amount of light reaches on the eyes. Okay, clear? Now look at this. There is a law, Rayleigh's law. Okay, Rayleigh's law state that scattering is inversely proportional to, look like inversely proportional, is like that. Scattering is inversely proportional to 1 by 1 by lambda to the power 4. It means that scattering, if the wavelength of a ray, is more, then the scattering is less. If the wavelength of a light or a wave is less, then the scattering will be more. Now here we know VGOR, the wavelength range for the VGOR is 4000 angstrom and the red light is 8000 angstrom. 8000 and 4000, which one having more wavelength? Red light. So red light is 8000, so the scattering will be the least. If wavelength is less, then scattering will be the more. If wavelength is more, then scattering will be the least. Now 4000 angstrom VGOR, violet light having wavelength is 4000, so it is less than 8000. So if the wavelength is less, then scattering will be the more. So that's why in all visible, that is VGOR, the violet light wavelength is least and red light wavelength is more. So the least wavelength having more, least wavelength means scattered most, and most wavelength, maximum wavelength, scattered least. Clear? So did you understand? Now you will understand that why violet scattered most, because of the Rayleigh's law. Scattering is inversely proportional to 1 by 10 to the power 1 by lambda to the power 4. It is not inversely proportional because it is 10 to the it is power 4. Okay, but it is look like inversely proportional. But we can say that if the value of the lambda is more maximum, then the scattering will be the minimum. Or if the value of the lambda is minimum, then scattering will be the maximum. Okay, just opposite. So here, violet, indigo, blue. Okay, they have small wavelength, scattered most. So violet, indigo and blue will scattered more. And yellow, orange, red, they have large wavelength, so they scattered less. Okay, mind it. Now Rayleigh's law valid only, this law, this equation, or Rayleigh's law equation, valid only when the size of the dust particle, the size of the dust particle will be smaller than the wavelength of the light. But what happen if the size of the dust particle is not smaller? Then if the size of the particle is more than the wavelength of the light, then what will happen? Then all colors scattered equally. All colors scattered equally. Rayleigh's law valid only those particles whose size must be smaller than the wavelength of the light. Rayleigh's law means scattering. Scattering is proportional to lambda to the power 4. So this equation will valid only the size of the dust particle is smaller than the wavelength of the light. But if the size of the dust particle is more, then what will happen? Then this is invalid. So what will happen? All colors scattered equally, means violet to green, violet to red, all scattered equally. Clear? Now look at this. Here's some application of scattering in our daily life. Now scattering is inversely proportional to, here 10 to the power 4 is missing. Just do correction in your notes, okay, which I have given. Scattering is proportional to 1 by lambda to the power 4. Okay, this is a Rayleigh's law. Now here VGOR is given. Wavelength of VGOR is 4000 and red color is 8000. So the wavelength among this, red is maximum and violet is minimum. So violet, if red is maximum, if this lambda is maximum, this wavelength, then scattering will be the least. So the red scattered least because wavelength is maximum. Violet scattered most because wavelength is minimum. Okay. Now look at this. Here is some question. Red color used for danger. Why the red color is always used for danger? Here you can easily answer this question. We can easily understand this why we use. Now look at this. Here least scattered, red color scattered least. Here, T is missing. Please do correction this one. It's a human error. Red color used for danger. Why? Because the red color light scattered least scattered travels long distance. Now look at this. Here red light and blue light. You are taking a blue light as a danger sign. Okay, but blue light scattered most. Here look at this. Scattered most. Blue, violet, indigo, blue. Okay, so these is scattered most. So blue light, if you use blue light or violet or indigo, then what happens? It will scattered most, and very few light will reaches to our eyes. But red light, they scattered least, like this, and it travels a long distance. So from long distance we can see the red light and we can stop. We are alert from a long distance by watching the red light. So this is the reason. Red light scattered least and travels a long distance. That's why we use red color light as a danger. Clear? Now, second point is sky appears blue most of the time. Not all time, most of the time sky appear blue. Why? Look at this. Here, this is our sun. This is earth. And these are the atmosphere. In atmosphere there is a dust particle. When the sun rays falls, then it will bend. Why this is bent? Because dust particle behaves as a prism or a medium. So one medium to another medium, the light bend. This is called the refraction of light. Okay. Now we know that the blue light, blue, indigo, violet, they have less small wavelength. Small wavelength means violet, indigo, blue. That wavelength is small, so the three scattered most. So they will scattered here. They will scattered most. So the dust particle, violet, indigo, blue light, the most. So the sky appears. They scattered most. Here scattered means missing. Scattered most, and they spread throughout the atmosphere. Okay. Wavelength of violet, indigo, blue. It's very small. So very small. If this is small, scattered most. Okay. So here the violet, indigo, blue will spread, scattered most, so spread throughout the atmosphere. And this is the reason the violet, indigo, blue will be appears. Okay. We do not see the red or orange. Okay. Most of the time. Clear? You can write in your own language that the violet, indigo, blue will having the wavelength is very small. So this color of light will scattered most, and they can spread throughout the atmosphere. So that is the reason we will see the blue. Blue is a dominant color among violet, indigo, blue. That's why we see the blue color of sky. The sky appears blue most of the time. Clear?